So today I want to take a closer look at trig identities and how they are used. One that we have talked a lot about is this one. If I know that sine of 10 degrees equals 0.1736. If I ask you for the cosine of 80 degrees, what's that going to equal? 0.1736. Why? Those are complements, right? And remember, cosine is saying sine of the complement. So the cosine of 80 should equal, better equal, the sine of 10, the sine of the complement. If I tell you that the tangent of angle A equals 2.73, and I tell you that A plus B equals 90 degrees, what is the cotangent of angle B? These two are once again complements, right? Cotangent means the tangent of the complement. So it better equal the tangent of A if they're complements, right? 2.73. It better be the same. So I don't have to have the angle there as long as I know that those are complements. They add up to 90 degrees. We have calculated some what we call reciprocal identities. We know that the secant of 30 degrees, what function do we use to find secant? Because our calculator doesn't have a secant key. It's 1 divided by cosine. Very good. Cosine of 30 degrees. It's reciprocal of cosine. So we could do 1 divided by the cosine of 30 degrees. Helps if I put the cosine in there. 1 divided by cosine of 30 degrees. 1.155. Or, remember the way we discussed doing it, you do cosine 30, close parentheses, then use that reciprocal key. So cosine 30, close the parentheses, x negative 1 is your reciprocal key. Gives you the same answer. And the reason we did that was so that when we went to do our inverses, it just reversed the steps. Of course, cosecant, if I want to do cosecant of 30 degrees, cosecant is the reciprocal of which function? Sine. Let's went over the sine of 30 degrees. So remember, we typed that in as doing sine 30, close the parentheses, then x negative 1. That better give us 2. And cotangent, 30 degrees is the reciprocal of tangent. So, and again, we did that as tangent 30, close the parentheses, did x negative 1, which gave us 1.732. Okay. So those are the ones we've covered already. Let's take a look at some other ones that are kind of interesting. And we started on this with you guys yesterday. But we know that the tangent of an angle is what two sides of a triangle? Opposite over adjacent. So we're going to leave that there for a second. Sine of an angle involves what two sides? Opposite over hypotenuse. Cosine is, careful, adjacent over hypotenuse. So if we divide the sine divided by the cosine, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So to divide, I'm going to take the top one, opposite over hypotenuse, times the reciprocal of the bottom one, hypotenuse over adjacent. And as I look at that, of course, we can cross-cancel hypotenuse, because this appears both spots. That results in opposite over adjacent. Does that look familiar? Yeah, that's the tangent. So the tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. Somebody pick a number between 1 and 89. 50. So let's let our angle equal 50. First, let's find the tangent of 50 degrees. .192. Let's find the sine of 50 degrees. 0.766. Let's find the cosine of 50 degrees. 0.643. So now if I divide sine divided by cosine, that's going to be 0.766 divided by 0.643. Now obviously there's going to be some round off errors here because we rounded those to 3 decimal places. But we get 1.191, which is our tangent. So if we know the sine and the cosine, we can find the tangent even if we don't know the angle. For example, let's say I tell you that the sine of angle D is 0.6 and the cosine of angle D is 0.8. What's the tangent of angle D? Sine D over cosine D. So yes, 0.6 over 0.8, which is 0.75. Now we know how to do an inverse function, right? We could actually find angle D here. How would we find angle D? Yeah, D would be the inverse sine of 0.6. .87 degrees. Or we do the inverse cosine of 0.8. .87. What's the tangent of 36.87? That'd be 0.75. And there it is. We could do an inverse tangent on this one. We should better get 36.87 as well. So what we have here, of course, there's the alternative to that. Since the cotangent of an angle is the reciprocal of the tangent of an angle, what do you think that means for the cotangent? Instead of being sine over cosine, it is cosine over sine. Whoops. I'll put the n in there. So if I know the sine of angle B is 0.5. And I know that the cotangent of angle B is 1.732. Find cosine of B, tangent of B, secant of B, and cosecant of B. Well, there's one that's going to be really easy to find. Which one directly links to sine? Cosecant. That's the 1 over the sine, right? So that's just going to be 1 over 0.5. The cosecant of B is 2. So that one's easy. Let's look at that tangent. Tangent's not going to be too hard to find because it's directly linked to cotangent. It's just going to be 1 over the cotangent, right? If cotangent is the reciprocal of tangent, tangent has to be the reciprocal of cotangent. So that's 1 over 1.732, which is what? 0.577, I believe, if I'm not mistaken. So really we're left with just cosine and secant. Let's look at finding that dear old cosine. We have cotangent here of B, and we know that that should equal the cosine of B divided by the sine of B. Right? Cotangent is cosine over sine. Do we know any of those pieces? Do we know the cotangent of B? Cotangent of B is 1.732, right? Do we know the cosine of B? No, that's what we're trying to find. Do we know the sine of B? 0.5, right? So now looking at this, if I want to solve for cosine of B, I could do this. I could put that over 1 and cross multiply and divide. 1.732 times 0.5 divided by 1 is going to equal 0.866. So cosine is 0.866. And now secant is going to be relatively easy to find because secant is 1 over cosine. So it's 1 over 0.866, which is 1.15. 1.155, I believe, isn't it? What do you think? Doable? I'm going to tell you that the cosine of angle A is 0.7071. I'm going to tell you that the tangent of angle A is 1. Find the sine of A, the cotangent of A, the secant of A, and the cosecant of A. Try that in your notes quick. Bless you. See what we got. I'm going to write down the lines. I'm going to start up there with the sine. To deal with the sine, I know the tangent. I know tangent of A is equal to sine of A over the cosine of A. So we know the tangent of A is 1. We're looking for the sine of A. We know the cosine of A is 0.7071. So to solve that, I'm going to put this over 1. We're going to cross multiply and divide to get the sine of A is 0.7071. Can anybody guess what angle we're dealing with here? If the sine and the cosine are equal, Must be a 45-degree angle. Cotangent is 1 over the tangent. So it's 1 over 1, which is 1. Secant is 1 over the cosine, which is 1 over 0.7071, which is 1.414. Cosecant is 1 over the sine. Well, since the sine is the same as the cosine, that's going to be 1.414. What do you think? Is it 1.414 or 1.404? .414, I was right. Okay. Not terrible? Cool. I'm going to show you something else that's kind of cool then. Unit circle. What dimension, in the unit circle, what dimension do we always know? The radius. And the radius equals 1. So there's my radius. If I were to tell you for this angle theta that the sine of angle theta here equals 0.5. From this drawing here, if this is cosine, could I possibly find that value for the cosine just by knowing the sine? How? I'll pull that triangle out here. That is just a right triangle. Exactly. I know this side is 1. This is 0.5. This is my missing side here. A squared plus b squared equals c squared. X squared plus 0.5 squared equals 1 squared. Well, the hypotenuse of this triangle is always going to be 1. What's 1 squared? 1. So the relationship here is always going to be, and I can switch the orders here, sine of an angle squared plus the cosine of that angle squared is always going to add up to 1 squared, or just 1. So here, to find the cosine of this angle, I would solve this equation. I'm going to trust that you guys know how to solve it. This would be the square root of 1 minus 0.5 squared, which is going to be 0.866. What do you think? So now, knowing this, all we need is one of the trig functions. The only catch is it can't be the tangent or the cotangent. But for example, if I were to tell you that the secant of angle M equals 4. Now I find the sine M, cosine M, tangent M, cotangent M, and cosecant of M. Well, here there is definitely one of them that I have to find first. Which one do I have to find first? Yeah, secant. The only one that secant is related to is the cosine. It's the reciprocal. Secant is the reciprocal of cosine. Cosine would be the reciprocal of secant. So secant is 4, so cosine is 1 over 4, or 0.25. Once we know that the cosine is 0.25, we can find the sine using that Pythagorean relationship. It'll be the square root of 1 minus 0.25 squared. In other words, sine of M squared plus that cosine of 0.25 squared has to equal 1. 1 squared. So the square root of 1 minus 0.25 squared 0.968 is the sine. Does that make sense? I'm going to stop. There's any questions on how I got that sine? Okay. Tell me how to find the tangent. Sine over cosine. So 0.968 over 0.25 is going to be 3.873. How about cotangent? We do cosine over sine. So 0.25 over 0.968. Or we could have done 1 over the 3.873, the reciprocal of the tangent. 0.2582. Is my cotangent. Cosecant. 1 over the sine. 1 over 0.968. 1.033. Now, when we are looking at these, there are certain restrictions we must meet. For example, both sine and cosine must be what values? No more than 1. They actually must be between -1 and +1. Right? Because they can be negative, but they can't be less than -1, and they can't be more than +1. So those must stay between -1 to +1. While we're at it then, what do we know about the secant and the cosecant? Yeah, they must be either greater than 1 or less than -1. Right? Just the opposite of the sine and cosine. Tangent and cotangent can be whatever the heck they want to be. So I'm going to have you guys try this one. If I tell you that cosine of angle P is 0.7, find the sine of P, tangent of P, cotangent of P, secant of P, and cosecant of P. Let's start out with the sine. So sine P squared plus cosine of P squared, that's just 0.7 squared, equals 1. .7 squared is 0.49. So now we're going to solve for sine. So we're going to subtract the 0.49. Sine of p, it's still squared, equals 0.51. So what do we have to do to solve? Square root. So we have 0.7141 for sine of p. How many of you got that? Just got the square root. So you had 0.51. On a test, that'll only cost you all the points. Tangent, how do we find it? .7141 over 0.7. Will give us 1.020. Cotangent, how do we find it? Cosine over sine, 0.7 over 0.7141. Or I could do the reciprocal of this previous one. Since that's in my calculator, that's what I'm going to do. 0.980. Secant. How do we find secant? It's the reciprocal of cosine. So cosine is 0.7. 1 over 0.7 is 1.4285714 approximately. So 1.429. I can go more digits if you want me to. Okay. Cosine of p is the reciprocal of, or cosecant of p is the reciprocal of sine. So 1 over 0.7141. 1.400. What do you think? Good stuff? Okay, for broadband, you guys are going to have homework. In that new packet I gave you, it's page 347 to 348 in that packet. I believe it's problem set 9.2 it's labeled, something like that. Have you do 1 through 35 the odds. You know, all these reciprocal stuff. Those of you in Woods, we're going to talk more in just a second. So I'm going to save this recording.